So for the first question, the question where he's giving you the dimensions, all right, and the parameter, number of cylinders, speed, power, and he asks for the mean piston speed, brake specific fuel consumption, or sorry, brake mean effective pressure, and the tau, which is the torque. All right, so you can get back here and see. So the first question, I will solve only for the example number 1. I will solve only for marine. All right, and you do the other things. So the pour was 136 millimeters, and the stroke is 127 millimeters, and number of cylinders was 12. The RPM was 2600 revolution per minute, and brake power was 1118 kilowatt. And he asks for mean effective mean piston speed, brake mean effective pressure, and torque. Or sometimes use this thing. All right. So for the first thing, mean piston speed. U of the piston is 2n multiplied by the stroke. This is going to be 2n is 2600, right, over 60, as I told you, to convert from RPM into revolution per second, and stroke length 127. It's in millimeter. I have to convert it into meter. So the mean piston speed is going to be 11 meter per second. This is the first thing. The second thing is the brake mean effective pressure. As I told you, the brake mean effective pressure is the brake power over displacement volume multiplied by n over 2. It's 4-stroke, and it's n, or it's n. It's going to be n over 2. So I put over 2 because it's 4-stroke. Okay. All right. So this is given to you here. The brake power is given to you. What we need to calculate here is the displacement volume, which is very easy. Is the number of cylinders multiplied by the area of the cylinder, or the volume of the cylinder, which is the area of the circle multiplied by the stroke length. All right, so number of cylinders 12, pi over 4, p square. The diameter was 136 millimeters, going to be 0.136. Divided by the stroke length is going to be 1.27, I believe. So displacement volume is going to be 0.022 meter cube. And we take this and substitute it here. You're gonna get. You have a question? Does anyone have a question?
Yeah. So, where did you get the 4-stroke? Like that, it's for a 4-stroke. Like, do you just assume it's 4-stroke since it's just a marine?
It's not written there.
Or where do you?
Yeah, I was wondering that the same thing with, because also for truck, it's
Yeah.
displayed either.
So I think the question is missing this 4-stroke 4-stroke hint. So please add it to the question. It is missing. Yeah, it is missing. Yeah, thank you.
Right, perfect. Thank you.
Thank you. All right. So, okay. Okay. So, sounds good. I'll get back here. So when we just substitute into the brake mean effective pressure, it is going to be 1118. This is kilowatt, and displacement volume 0.022 multiplied by n. N is 2600 over 2600 over 2 multiplied by 60. Don't forget to divide by 60 in order to convert it from RBM to RBS. Okay. So the brake mean effective pressure is going to be 23.3 bars. The last thing is the torque. Do you guys know from where I can get the torque? Do you guys know from where I can get the torque? Please. Any?
Would it just be power divided by 2 pi n?
Yes, exactly. Thank you. From the brake power equation. Thank you. So, all right. Just one moment, I'm checking something over here. Okay. So the torque is, or from the brake power equation, torque multiplied by omega. The brake power 1118, torque omega is 2 pi n over 60. N is 2600, so the torque is 4.106 kilonewton per meter, or kilonewton meter. Kilonewton meter, right? I think it's kilonewton meter. Yeah, Newton meter. Right? Okay.
I'm not sure if others got that answer or not. When I had calculated the two values,
Yeah.
I got the BMAP to be 2.34 bar, and then I had gotten the torque to be 410 Newton meters.
Why did you forget 0? Because it's 23.3. It's like you forget something. Can you double check you substituted with the correct thing values?
I had initially found the torque, and then I solved for the BMAP. So
Nice.
I had done the power. Am I supposed to use the power when substituting into the torque in kilowatts or watts?
In kilowatts.
Oh, okay. Then there's my issue. Okay.
Yeah, in kilowatts, and it is gonna, if you substitute here in kilowatts, it's gonna give you kilonewton over here. If you substitute in watt, it's gonna be newton. That's good. All right.
Yep,
So yeah, no problem. So that's for the first question. The second question is very easy. It's about the volumetric efficiency. So the second question 2. Can I get back here? So volumetric efficiency of fuel injected in table 1 is 0.8, and inlet manifold density that is giving you the density is higher than the atmospheric density, which is the atmospheric density is 1.17. If the engine speed is, what is the air mass flow rate? So he give you the value of the volumetric efficiency. So the volumetric efficiency is 0.8. And as I told you, the volumetric efficiency m dot actual, m dot air actual over m dot air, the theoretical one, which is coming from the engine, the cylinder dimensions. So he's asking for the actual air mass flow rate. So this is going to be n volumetric efficiency 0.8 m dot actual or m dot over rho displacement volume multiplied by n over 2. So rho is 50% higher than the 1.17. So it's 50% higher. So let me clarify it. So rho of air at this point is 1.5 multiplied by 1.17, which is given. So 1.17 also is rho of air of ambient air. Correct. So this is the rho of ambient air. So rho of air that is going to be used here is going to be 1.755 kilogram per meter cube. And when we substitute it here, we have VD is 0.022 as we calculated before, and N is 2600, and I have to divide it by 60. So it's going to be then multiplied by 2, which is this 2, right? So m dot air, if you are calculating what is the m dot air then? Can anyone answer me? If you're calculating the m dot air, what is the m dot air, please? Thank you. Do you guys get it? Right, it's 0.669 kilogram per second. So that's for question number 2. Any questions? So question number 3 is a single cylinder, right? It's 2-stroke engine, single cylinder with it's 380 cc single cylinder and two-stroke. So do you know what is cc? This engine is running at an RPM of 5500 RPM. All right. The bore diameter is 82 millimeters. The stroke length is 72 millimeters. And brake mean effective pressure is also given to you, which is 6.81 bar, and brake specific fuel consumption is 0.49 kilogram per kilowatt hour, which is 490 gram per kilowatt hour. Okay. So what is requested here is the fuel to air ratio. and air mass flow rate. So whenever air mass flow rate is requested from you, you know that you're going to use the volumetric efficiency, right? So, right, or it's going to be given from the volumetric efficiency, right? So the volumetric efficiency is also given to you. Eta volumetric is 0.748. That's good. Okay, let's solve this thing. All right, so CC 380. CC is cubic centimeter. Cubic centimeter, right? So this is one also can be specifying an engine, or he can tell you that this is a 4-liter engine. So you know that the displacement volume is 380, or multiplied by centimeter. I have to convert it into meter, and because it's a cubic, right? So I have to add the power 3 here. So displacement volume is going to be 3.8 multiplied by 10 to the negative 4 meters, right? So this is the displacement volume, which is already given to you directly. You can also have the displacement volume from the equation I told you about. If you calculate it from this way, or you get it from this way, the other way, which is the number of cylinders multiplied by over 4 p square s. Number of cylinder is 1 because it's a single cylinder. By over 4 p square is 0.082 all square, and multiply by, sorry guys, it's gonna be multiplied by s, which is 0.072, and this also gonna give you displacement volume of 3.8 10 to the power negative 4 meter cube. All right. So it's either given to you like this way, or you can calculate it from the dimensions here and based on the number of cylinders as well. Okay. So this is the first thing we have to calculate. So the fuel to air ratio. First thing we have to do is we need to get the mass flow rate of the fuel, and we need to get the mass flow rate of the air, and divide them to each other. We're gonna get the fuel to air ratio. So from where we can get the fuel mass flow rate? From what given? You guys with me? Can anyone answer anything? Just need to see that. Yeah.
From the brake specific fuel consumption.
Yes, please. Yeah, thank you. So from the brake specific fuel consumption, it's equal to m dot fuel over the brake power. All right. Sorry. Yeah. So we don't have m dot fuel and we don't have brake power. How are we going to get the brake power then? From what given? From here, from the brake mean effective pressure, right? So brake mean effective pressure is brake power over displacement volume multiplied by N. Do I have to add over 2 here? So the brake power is 6.81 bars, and I have to multiply by 100 in order to get it in kilopascal, because I want to get the brake power in kilowatts, right? So this is going to be brake power. So I have to remove N from here because it's one stroke. It's two-stroke engine, sorry. Okay. So displacement volume multiplied by N. Then N here is 5,500 revolution per minute. All right, sounds good. So the brake power is 23.71 kilowatt. And I can take this brake power and put it over there. Do you think, is there anything missing here, guys? If you are with me? Brake specific fuel consumption was 490 or 0.49. kilogram per kilowatt hour. M dot fuel over the brake power. Do you guys think that is there anything missing in this equation?
Conversion into seconds.
Yeah. Okay. So it's gonna give you 23.71. And M dot fuel, then we can get M dot fuel out of here. So the brake power we get 23.71. M dot fuel in that case is gonna be 11.62 kilogram per hour, because this is kilogram per kilowatt hour. Okay. And it's in kilowatt. This one is in kilowatt. All right. So that's for M dot fuel. Sounds good. What about M dot air? How are we gonna get M dot air? So M dot air from the volumetric efficiency. So M dot air over rho air V displacement N over 2. Okay. Also here I have to cancel out 2 because it's two-stroke engine. So the volumetric efficiency was given 0.74 something. 0.748. M dot air over density of air is 1.17. Volumetric 3.8 multiplied by 10 to the negative 4. N is 5,500 over 60. Okay, so M dot air from this case is going to be 109.74 kilogram per hour. And this is given number requirement number 2. And requirement number 1 is the fuel to air ratio. M dot fuel over M dot air, which is 1.62 over 109.74 is going to give you 0.0304 without any unit, because it's a ratio. All right, so do you guys have any question? Was that clear? I'm done with the tutorial. So I just want to check with you something. All right. So do you guys have any? Do you guys have any other questions? Was that clear? Do you like this style, or you like the style of presentation, or what do you think? Like I can show the but I don't like this way honestly. But if you like it, I can do it. I can show the tutorial, like the tutorial section or the PDF file in one side. I can show the solution in the other side, and I just presenting the solution, not writing it this way. So what do you think? Do you like this way more, or do you like the presentation model? What do you think, guys? Can anyone talk?
Yeah, that seems okay.
That one is good. Okay, that one is good.
Yeah.
All right.
We just have a small question. Are you going to be uploading the?
Yes, of course. I'm gonna
Yes,
upload
yeah.
the
Perfect. Thank
handwritten
you very
thing.
much.
I'm gonna upload. I don't know if the instructor uploaded the tutorial. He uploaded the tutorial, right?
Yeah, but not the solutions. We just went through the solution.
All right. So I will be uploading the solution once I have access, because I don't have access to the canvas.
I
So
think everyone is answering your question and they're typing questions in the chat, but I don't think you can see the chat.
I can see it right now, because like when I'm writing, I turn my laptop into tablet mode, so I cannot see the question at all.
Yeah, I just wanted to let you know. Thank you very much.
No problem. Thank you. I like going through the problems and seeing where everything is coming. Okay, nice. So okay, another thing I would like to ask you again. Well, again, what about the introduction, like the spending 20 minutes at the beginning, reviewing what was given in the lecture?
Personally, I like that. It's like
Yeah.
it's a good review. So like you get a refresher after all the other courses that you just came from. You go your way back to combustion and engines, and then you do the questions.
All right. So it's good as well, because sometimes people would like to solve more questions instead of reviewing. But I feel like you are somehow need someone to remind you what's going on in the lecture, and then I can solve problems, so you can be with me. All right. So sounds good. Confirmed. I will start recording from the next time, from the beginning of the lecture. I will upload this to my YouTube channel, and I will share the link with you if you guys want to review them later. Maybe it's up to you. All right. Thank you very much. I see you next time. Take care. Are you able to put your mic close to your mouse? This is the closest thing I can. I'm sorry. I will try to use another mic next time. This is the closest thing, because it's my gaming headphone. Okay. Thank you very much. Thank you very much. I appreciate it. Have a nice day. Thank you. Have a nice day. Thank you.